The first question is, what is the number of turns on the primary side? Second one, what is the current on the primary side? Third one, what is the amount of transformed power? And fourth one, the fourth one comes afterwards. Okay, first we're gonna use a relationship between voltage and turns to solve question A. Question A, we're gonna use this relationship, which is number of turns on the secondary coil divided by the number of turns on the primary coil is the voltage on the secondary side, like divided by the voltage on the primary side. So we're gonna use this and to show you how to get this equation to show n1 on this side. I'm gonna do it in steps. So we wanna have n1 not in the denominator but up here. So I'm gonna multiply by n1. So this leaves n2 here, and u out divided by u in times n1. Okay, now we're gonna want to have this one on the other side. So divide this by u out, moves this from there to there, and multiply by u in from there to up there. So u in times n2 divided by n1. No, sorry. U out. Now this is n1, and we have some numbers for our values. Put them in here. We have u in 220 volts, u out 9 volts, I out 440 milliamperes. Gonna have to write something about that. And a secondary coil has 30 turns. So we have 220 volts times 30 turns divided by 9 volts. So volts and volts eliminated, turns is left. That gives 733.3 turns on the primary coil. So why did I say I have to say something about this? This is not the SI unit. It is a unit that makes it easier to write the right numbers, because 440 is easier to calculate with than with 0.44 amperes. So, but you should, for getting a correct result, you should write it in SI. So this 440 milliamperes is the same as 0.44 amperes. Okay. For B, we can use an equation like that, or we can use the power, because there's the power equation in the transformer. It's easy as that. And this one u in times I in equals u out times I out. So voltage times current is power. So we can transform this again. We want u in, so u out I out divided by U in is I in, and if we now do the 9 volts and 0.44 amperes, we have 220 volts, we have 0.08 amperes, and this is 18 milliamperes. Okay, if you have a high number of turns in the primary coil, this happens. The voltage on the secondary coil goes down, and this is what we wanted. So go, and finally, we see the power is the same, so we need power transformed as P in is P out is the same. Okay, and now we can use 220 volts and 8 amperes. This one I leave for you. You can write it in the comments if you want, as well as the fourth task. Can I use the transform with transformer with direct current? So this one concludes our little exercise, and I hope that it was helpful for you.